According to Article 100 of the National Electrical Code, an individual branch circuit is defined as a circuit that supplies only one or more utilization equipment, originates from the distribution panel board or other supply source, and is protected by an overcurrent device of appropriate capacity. A receptacle is a type of utilization equipment, but it is specifically designed to provide a connection point for portable or plug-connectable equipment. The key distinction is that the receptacle itself does not use electricity. It merely provides a means to connect other devices that do consume electricity. Individual branch circuits must be sized to provide adequate current to the utilization equipment they serve. This means the load on the branch circuit is calculated based on the ampacity of the connected equipment, not the ampacity rating of the receptacle. To further clarify, consider the following points. Firstly, utilization equipment is defined as equipment that utilizes electric energy for electronic, electromechanical, chemical, heating, lighting, or similar purposes. A receptacle does not directly perform any of these functions. Secondly, receptacles are rated in amps to indicate the maximum current they can safely conduct, not the amount of current they consume. This rating is crucial for safety to prevent overheating and potential fire hazards when devices are plugged in. Thirdly, the overcurrent protection for an individual branch circuit, such as a circuit breaker or fuse, is selected based on the ampacity of the conductors in the circuit and the load of the utilization equipment. If the receptacle were considered the load, the overcurrent protection would be inappropriately sized, potentially leading to unsafe conditions. Therefore, since a receptacle is not utilization equipment that consumes electricity and does not have an ampacity in terms of consumption, it does not meet the definition of an individual branch circuit. The individual branch circuit must be sized based on the load of the equipment that will be connected to the receptacle. To illustrate this with an example, imagine a 120 volts, 15 amps receptacle connected to an individual branch circuit. The receptacle itself doesn't draw any current, but if you plug in a space heater that draws 12 amps, the branch circuit must be capable of supplying that 12 amps load continuously. The circuit breaker protecting the branch circuit would be sized appropriately, typically at 15 amps or 20 amps, depending on the wire gauge and local electrical codes. Now, consider another scenario. Suppose you have a dedicated 20 amp circuit for a specific appliance, such as a refrigerator. The refrigerator is the utilization equipment, and the branch circuit is sized to accommodate its power requirements. The receptacle used to plug in the refrigerator is simply a connection point and is not the determining factor in sizing the branch circuit. Another important aspect to consider is the application of the National Electrical Code, specifically Article 210.21, which deals with receptacle outlets. This section outlines the permissible loads that can be connected to various receptacle circuits. For example, a 20 amps branch circuit can supply multiple 15 amps or 20 amps receptacles, provided the total load does not exceed the rating of the circuit. This further emphasizes that the branch circuit serves multiple points of utilization, rather than being solely dedicated to a single receptacle as the defining factor. Moreover, the NEC provides guidelines on the number of receptacles required in different areas of a building to ensure convenience and safety. These requirements are based on the anticipated usage of electrical appliances and equipment, not on the individual receptacles themselves being considered branch circuits. Let's also discuss the difference between a general-purpose branch circuit and an individual branch circuit. A general-purpose branch circuit supplies two or more receptacles or outlets for lighting and appliances, while an individual branch circuit supplies only one piece of utilization equipment. The key is that the individual branch circuit is dedicated to a specific load, and that load is the utilization equipment, not the receptacle. To summarize, an individual branch circuit is defined by the utilization equipment it serves, not by the receptacle that provides a connection point. The receptacle is a component within the electrical system that facilitates the connection of various devices, but it does not define the characteristics or requirements of the branch circuit itself. The sizing of the branch circuit is based on the ampacity of the connected equipment, ensuring that the circuit can safely handle the load without overloading. Remember that safety is paramount in electrical installations, and proper understanding of these concepts is crucial for electricians and anyone working with electrical systems. Always consult the National Electrical Code and local electrical codes for specific requirements and guidance. When installing or modifying electrical circuits, it is essential to follow all applicable codes and regulations to ensure safety and prevent electrical hazards. Incorrect wiring or improper sizing of branch circuits can lead to overheating, electrical fires, and other dangerous situations. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They have the knowledge and experience to perform the work safely and correctly. Furthermore, consider the implications of using extension cords and power strips. While these devices can be convenient for connecting multiple devices to a single receptacle, they can also pose a safety risk if overloaded. It is important to use extension cords and power strips that are rated for the intended load and to avoid plugging too many devices into a single outlet. Overloading a circuit can cause the circuit breaker to trip, but it can also lead to overheating and potentially a fire if the circuit breaker fails to function properly. It is also important to inspect extension cords and power strips regularly for any signs of damage, such as frayed wires or cracked housings. Damaged cords and power strips should be replaced immediately to prevent electrical hazards. In addition to the NEC, other standards and regulations may apply to electrical installations depending on the location and type of building. For example, commercial buildings may have different requirements than residential buildings. It is important to be aware of all applicable codes and regulations and to ensure that all electrical work complies with these requirements. Also note that electrical codes and standards are constantly evolving to reflect advancements in technology and improvements in safety practices. It is important to stay up to date on the latest changes to the NEC and other relevant standards. This can be accomplished by attending training courses, reading industry publications, and consulting with experienced electricians. In conclusion, understanding the distinction between a receptacle and an individual branch circuit is essential for safe and compliant electrical installations. The receptacle serves as a connection point, while the branch circuit provides the power to the utilization equipment. Sizing the branch circuit based on the load of the connected equipment is crucial for preventing overloads and ensuring safety. Always consult the NEC and local electrical codes for specific requirements and guidance, and never hesitate to seek the advice of a qualified electrician if you have any questions or concerns. Keep in mind that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. By following these guidelines, you can help ensure that your electrical systems are safe, reliable, and compliant with all applicable codes and regulations. Always remember to turn off the power at the circuit breaker before working on any electrical circuits or equipment. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. Never work on electrical systems in wet or damp conditions. If you are unsure about any aspect of electrical work, it is always best to consult with a qualified electrician. They have the knowledge and experience to perform the work safely and correctly. Staying informed about electrical safety and best practices is a continuous process. By investing in your knowledge and skills, you can contribute to a safer and more reliable electrical infrastructure for yourself, your family, and your community. Furthermore, consider the importance of proper grounding in electrical systems. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. This helps to prevent electrical shock hazards and protect equipment from damage. It is important to ensure that all electrical equipment is properly grounded and that the grounding system is properly installed and maintained. In addition to grounding, arc fault circuit interrupters, or SIs, are another important safety device that can help to prevent electrical fires. SIs detect arc faults, which are dangerous electrical conditions that can cause fires. When an arc fault is detected, the SI will trip and energize the circuit, preventing a fire from starting. SIs are required in many areas of the home, such as bedrooms and living rooms, and it is important to ensure that they are properly installed and functioning correctly. Surge protectors are another important device that can help to protect electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protectors work by diverting excess voltage away from the electronic equipment, preventing it from being damaged. It is important to use surge protectors for sensitive electronic equipment such as computers, televisions, and stereos. Regular maintenance of electrical systems is also essential for ensuring safety and reliability. This includes inspecting wiring for damage, tightening connections, and testing circuit breakers and ground fault circuit interrupters, or GFCIs. It is also important to keep electrical panels and equipment clean and free from dust and debris. Dirt and dust can accumulate on electrical components and cause them to overheat, which can lead to failures and potentially fires. If you notice any signs of electrical problems, such as flickering lights, sparky outlets, or burning smells, it is important to investigate the problem immediately. These symptoms could indicate a serious electrical issue that needs to be addressed by a qualified electrician. Ignoring electrical problems can lead to more serious damage and potentially dangerous situations. In addition to the technical aspects of electrical systems, it is also important to be aware of the human factors that can contribute to electrical accidents. These factors include fatigue, stress, and lack of training. It is important to be well rested and focused when working on electrical systems and to avoid working on them when you are feeling stressed or distracted. Proper training is also essential for anyone working with electrical systems. It is important to understand the hazards involved and to know how to work safely. Finally, remember that electricity is a powerful force that can be dangerous if not treated with respect. By following safety precautions and staying informed about electrical best practices, you can help to prevent electrical accidents and ensure the safety of yourself and others.